This video addresses NC Math 1A REI 4, which is solve for the real solutions of quadratic equations in one variable by taking square roots and factoring. Today we are going to factor a quadratic equation to find the solutions. In the unpacking document, the students should focus on solutions with one or two real solutions. This standard also gives algebraic reasoning of how to solve a quadratic to find the solutions, which are also the roots, the zeros, and the x-intercepts. And lastly, it gives the how to solve a quadratic equation. The strategy I chose to demonstrate is using algebra tiles. And at this point, I have shown my students how to use the algebra tiles with multiplying polynomials. Therefore, they have somewhat of a basic understanding, but I'm going to review just a little bit. As you may recall, the large blue square represents the x squared tile because this side length is x, and if this is a square, that means all sides are equal, so side times side is x squared. Then we have the long green tile. This tile is the same length as one of our large square tiles. So that means that this length is x, but the width would be 1. So this one is just a single x. And then we have our small square tiles. And if you'll notice, they are the same width as the long green one. So that length or width is 1. And since it's a small square, that means all sides are 1. So these are 1 tiles. You can also turn these over so that it will denote the negative aspect of your quadratic equation. But whenever it is on the other side, it represents the positive. So these are the positive numbers, and again, the other side is the negative numbers. So the first example that we're going to look at is x squared plus 8x plus 12. Okay, I'm going to draw my axes, and this just helps me to remember that I am supposed to be making a square or a rectangle. That is the purpose behind using algebra tiles. It builds on the understanding of the area of a square. Okay, so if you look at your first term, it is x squared. I don't see a number in front of it, but there is a number. It's implied. It's 1. Okay, so I have 1 x squared term. My coefficient with my middle term is 8, so I'm going to pick 8 single x tiles. And then my last term is 12. I'm going to pick 12 of my 1 tiles. 12 is also your constant because I don't have a variable. It's also your y-intercept of your quadratic equation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, and 12. Okay, so the point, or our goal, is to create a square or a rectangle. The large blue x squared tile always goes in the top left corner. And then I start with my the middle term, which are my x tiles, and I place them along the sides of my x squared term or tile. And remember, since this side is x, I have to place these tiles along the x side as well because that means they're the same distance. Okay, so I'm just going to put 3 up here, 3 down here. I have 2 left over, so I'm going to do even 1 and 1. So I have 4 on that side and 4 on this side. Now this little area right here is where all of these tiles should fit in. So I start placing these. To form a rectangle or a square. And you can see that I'm short. I don't have enough of my 1s to fill in right here, so this is not a good format. I can't use this. So I have to rearrange. I'm just going to take this one and move it down here. I'm going to take these three and try to filter them in. Again, same scenario. I don't have enough 1 tiles to fit, so I'm going to move again. I'm going to move this X one down here, and I can move from this way up here or from here down. It doesn't matter. It's still going to be side times side, or length times width. So then I filter these in and it works. I now have my rectangle. So what exactly are the factors? I have made my rectangle out of the tiles that I used from my quadratic equation x squared plus 8x plus 12. If you recall, the x squared term represents side length x and x. So this side is x, this side is x. X times x is x squared. Now I have, since this side was 1 and the long side was x, I have 2 of those. Over here I have 1, 2, 3, 4, 5, 6. When you take your 2 and your 6 and you multiply them together, you should get however many 1 tiles that you have here. And 2 times 6 is 12. I have 12 1 tiles. Alright, so my 2 factors are listed here as your dimensions. X plus 2 and x plus 6. Now you may ask, well, how did you know to use a positive and not a negative? Since these are my green tiles, they denoted positive numbers. Whatever the sign of this number is, that is your operation. So since this is a positive 2, it is my operation of adding. Since this is a positive 6, it's my operation of adding. Now I'm going to use the zero product property and set both of these equal to 0. I'm subtracting 2 from both sides. I get x equals negative 2. Subtract 6 from both sides. X equals negative 6. So my 2 solutions would be negative 6, negative 2. So by using the algebra tiles, the students were able to solve for the real solutions of a quadratic equation in one variable by taking square roots and factoring, and in this video we focused on factoring. The vertical progression of this standard shows that students first start factoring in 7th grade with 7.EE.1, where they factor linear expressions with rational coefficients. In 8th grade, they use the square root to represent solutions to equations in the form of x squared equals p, where p is a positive rational number. And then in Math 1, which is the standard that we looked at today, where they're solving for the real solutions of a quadratic equation by factoring. And then it progresses into Math 2 with the same standard, but this time it includes solving quadratic equations by completing the square and quadratic formula, as well as explaining any non-real solutions.